I have done a lot of research trying to figure out the material of the class, when actually you don't need to try to figure it out. I'm giving it to you. I'm taping it, I'm posting. So there's no need to go do research for the class material. You just need to read your notes, watch the videos, do the problems. 3 steps, which I think are simple. So now we are on, we are already live, and we are waiting to start. So we got one more person in. Hello, welcome. So like I said, today we are going to solve all kinds of applications of Laplace transforms, and very first one would be this differential equation that I'm going to solve with you right now. Okay, admit everybody. First says 1, solve. Somehow it seems people have discovered that I was in a car accident, and then so they are calling me every time to propose their services. Strange, right? So this is the problem that we want to solve. Second derivative plus 4 times the first derivative plus 4y equals t cubed e to the 2t, where y of 0 is equal to 0 and y prime of 0 is equal to 0. And so, and I give you this problem, if you try to do what we used to do, method of undetermined coefficients or variation of parameters, we'll spend at least 15 minutes solving this problem. But if you do what we do now, then you will see that this problem is actually very easy. Doesn't take that much time. So there we go. First step, apply Laplace transform to both sides. That's it. So that's Laplace transform of second derivative plus 4 Laplace transform of the first derivative plus 4 Laplace transform of y equals Laplace transform of t cubed e to the 2t. That's it. And then on the side, you can remind yourself Laplace transform of the derivative is s Laplace transform of y minus y of 0. And that is s Laplace transform of y because y of 0 is given as 0. Laplace transform of second derivative is s Laplace transform of y prime minus y prime of 0. And that is s, and Laplace transform of y prime is s Laplace transform of y, so that's s squared Laplace transform of y, and y prime of 0 is 0. And so Laplace transform of t cubed e to the 2t, tell me how you get this one. Anyone to tell me what's the Laplace transform of t cubed e to the 2t?
Get the idea of what exposure is, all of their theories get a whole lot better almost immediately.
Dr. Longworth, would
Yeah,
you find the Laplace of t cubed and then plug in s minus 2?
that's what it is. So what is it? What do we get?
6 over s minus 2 to the fourth.
That's right. And so you take all those in here. Laplace transform of second derivative, that's s squared, plus transform of y, plus 4s Laplace transform of y, plus 4 Laplace transform of y equals 6 over s minus 2 to the fourth. And again, so sorry to hear, we can just replace this because it's actually a minus in the original problem, but we can still solve the problem with a plus. It doesn't change anything. Okay. So the original problem comes with a minus, not a plus. And so here, you solve for Laplace transform of y, that's s squared minus 4s plus 4. Laplace transform of y equals 6 over s minus 2 to the fourth. And this is s minus 2 squared. Laplace transform of y equals 6 over s minus 2 to the fourth, or Laplace transform of y equals 6 over s minus 2 to the power 4 plus 2, 6. So that's what you get. Then you find the inverse Laplace transform. To get y of t. So y of t is inverse Laplace transform of 6 over s minus 2 to the power 6. And again, like I said, we are professionals. So right here, we recognize first translation theorem. So that's going to be e to the 2t, and then inverse Laplace transform of 6 over s to the 6. And that is 6e to the 2t, and then divided by 5 factorial, inverse Laplace transform of 5 factorial over s to the 6, which is y of t equals 6 over 5 factorial e to the 2t times t to the power 5. 6 factorial, 5 factorial is 5 times 4 times 3 times 2. 3 times 2 can cancel. So you get 1/20th t to the 5th e to the 2t. So that's the solution of the problem that already incorporates the fact that y of 0 is 0, and y prime of 0 is 0. Now I'm gonna let you do the next one. That's gonna be y double prime minus 4y prime plus 4y equals t cubed y of 0 equals 1, y prime of 0 equals 0. These follow exactly the same step. Giving you 5 minutes for that. So, you want with the answer? So, want to try, Messi?
I have the first half. I'm stuck on the second half.
Well, let's go first to that first half. Tell me what you get.
So the first thing I did was transform the function into s squared times Laplace transform of y minus 4s Laplace transform of y plus 4 Laplace transform of y equals Laplace transform of t cubed. Then basically did what we did on the last one where it was
And you got to go step by step and tell me what you got for each of them. What's the Laplace transform of y prime?
oh wait I messed something up.
All right, that's the thing. When you jump on a step, that's where you get the mistakes. So what's this one?
It's going to be s times the Laplace transform of y minus y0, and y0 is 1.
1. That's it. And so what's the Laplace transform of second derivative?
It's going to be s times the Laplace transform of y prime minus y prime of 0.
And this is Laplace transform of y prime is that. And then y prime is 0. So this is s squared Laplace transform of y minus s. And then what's the Laplace transform of t cubed?
It's 6 over s to the 4th.
That's it. And now when you put those in the equation, that's now s squared Laplace transform of y minus s minus 4s Laplace transform of y plus 4 Laplace transform of y equals 6 over s to the 4. That's the first step. Now, if we want to continue on this problem, after that first step, we need to put the problem on the side. Then you got to solve. You got to solve for the Laplace transform of y. So that's s squared minus 4s plus 4 Laplace transform of y equals, and the s goes to the other side, s plus 6 over s to the 4th, which brings us to Laplace transform of y equals s over s squared minus 4s plus 4 plus 6 over s to the 4th times s squared minus 4s plus 4. That's it. And notice that I did not combine these things. Combining would be a useless exercise to do. You'll be creating more problems for yourself when you combine them. And now you got to find the inverse Laplace transform. So y of t is inverse Laplace transform of s over s squared minus 4s plus 4 plus inverse Laplace transform of 6 over s to the 4th, and this is technically s minus 2 squared. All right, and there are two ways to look at this. This first one can be computed easily. This is L minus 1 of S over S minus 2 squared. L minus 1 of, and I can write this as 6 over S to the fourth times 1 over S minus 2 squared. This first one can be written as S minus 2 plus 2 over S minus 2 squared. And that second one, this is inverse Laplace transform of a product. So convolution theorem gives you here that this is t cubed star. And what is the function that turns into this? What is the function that has Laplace transform 1 over S minus 2 squared? Hello. Are we together?
Isn't this where you use the negative derivative with respect to s? And that's how you got the answer. Because I know that it's supposed to look like 1 over s squared, because then the derivative of that would be negative. Well, it'd be,
you are
I don't
going
know.
you are going too far into that. You would still get the answer with that, but it is too much for just that. You will get the answer with what you're saying, but you work more than needed.
That's just the first translation theorem, isn't it?
That's standard first translation theorem. So S minus 2 goes out, that's 1 over S squared. What is the function that has the Laplace transform 1 over S squared?
T.
T. So that's T e to the 2t. That's it. Now, if you do all the work that Miss is saying, you still get that. You still end up with that. So right here, it's first translation theorem. And then from here to here, that's the convolution theorem. And that's why you need to be ready with all the topics before doing this. So you got first translation theorem, you got convolution theorem to get out of here, and then you got splitting here to get out of the first one. So you split this, it's going to be inverse Laplace transform of 1 over S minus 2 when we take this over that, plus 2 over S minus 2 squared, plus t cubed, or I can say t e to the 2t star t cubed. So what's the function that has Laplace transform 1 over S minus 2?
E to the 2t.
E to the 2t. And the 2 over S minus 2 squared?
Two T e to the 2t.
2t e to the 2t. So those are the first two. And then here, you can now write this convolution integral from 0 to t f of tau. So that's tau e to the 2 tau times t of t minus tau and t minus tau cubed d tau. Or you can write that as integral from 0 to t of tau cubed times t minus tau e to the 2 times t minus tau. It's actually a better way to write it. And you know that computing, you will get the same answer. All right. So that's what you get here. And we are going to integrate this thing by parts. It's integral from t0 to t of t tau cubed minus tau to the fourth e to the 2 times t minus tau d tau. And now we can go by parts. This is dv, and that's u. So when you integrate that, you're going to get uv, so that's t tau cubed minus tau to the fourth times e to the 2 times t minus tau over minus 2 from 0 to t minus integral 0 to t, and then the derivative of this is going to be 3t tau squared minus 4 tau cubed, and then times e to the 2 times t minus tau over negative 2 d tau. That's the first step. Then you plug in t and then 0. When you plug in t here, you get 0. When you plug in 0 for tau, you get 0 as well. So this first integral gives us a 0. And I can remove this 2 from here, and I get 1/2. And then I integrate by parts again. That's now this is going to be the u, and the other guy will be the dv. So it's going to give me 3t tau squared minus 4 tau cubed. That's u, and v is going to be same as in the previous. T minus tau over minus 2, 0 to t minus integral 0 to t. Derivative of this is going to be 6 t tau minus 12 tau squared times e to the 2 t minus tau over minus 2 d tau. Again, we plug in the numbers. So it's 1/2. When you plug in t here, you get 3t cubed minus 4t cubed. It gives you minus t cubed. E, and then t minus t is 0, so that's 1 over minus 2. It becomes plus 1/2. Minus, when you plug in 0, you get 0. So you're left with the part that is here. So minus and minus again, that's plus 1/2. And then we compute again the integral. The 1/2, we can actually get that 1/2 inside. So be plus 3t tau minus 6 tau squared e to the 2 times t minus tau d tau. That'll be t cubed over 4. That's 1/2. And again, we integrate by parts. This is u, and that's dv. So that gives us 3t tau minus 6 tau squared e to the 2 times t minus tau over negative 2 from 0 to t minus integral 0 to t. Derivative of this is going to be 3t minus 12 tau, and then e to the 2 times t minus tau d tau over negative 2. Then we do the same work that we did in the previous one. We plug in t, that's 3t squared minus 6t squared. It's negative 3t squared over 2. So that it is over negative 2, though. So that's plus 3 halves t squared. Then we plug in 0, and then tau and tau, that turns into 0. And so we get minus, minus, and minus turns into a plus. 1/2 integral 0 to t 3t minus 12 tau e to the 2 times t minus tau d tau. Now we can open these parentheses, so that's t cubed over 4 plus 3/4 t squared plus 1/4. And now we compute the integral by parts again. So that's 3t minus 12 tau e to the 2 times t minus tau over negative 2, 0 to t minus. Now the derivative of this, that's integral 0 to t. Derivative of this is going to be minus 12 e to 2 times t minus tau over minus 2 d tau. So that will be the last integration by part. So this gives us t cubed over 4 plus 3/4 t squared. When we plug in t here, we get 3t minus 12t. That's minus 9t over 2 over negative 2. That's plus 9 halves and the 1/4. So that's 9/8 of t. Then we plug in 0. And when we plug in 0 here, this becomes 3t e to the 2t. And with the minus here, it becomes plus. Minus minus becomes plus. So that's plus 3. And then 2 times that. So that's 3/8 t e to the 2t for this piece. And now we have the last piece, which is this integral. So minus, minus, and plus, that turns into minus. And then 12 over 2, that's 6. Okay. So we get 1/4. And then 6. When you integrate, you get 3 minus 3 e to the 2 times t minus tau from 0 to t. That's it. So what does this one give us here? When you plug in t, you get a constant 0. That's minus 3. So it gives you, let me here, It gives you plus 3/4 when you plug in t. And when you plug in 0, you get minus, and this minus becomes plus, and this minus, it's minus. So that's minus 3/4. E to the 2t. So this piece is equal to that. And so you add it to this one to get the final answer for y of t. So the solution of your problem is y of t equals t cubed over 4 plus 3/4 t squared plus 9/8 t plus 3/8 t e to the 2t minus 3/4 e to the 2t plus 3/4. Any questions? Second part of this application is what we call the integral differential equations. An example here would be solve f of t equals 1 plus t minus 8/3 integral from 0 to t of tau minus t cubed f of tau d tau. We want to solve this problem. That's the second kind of application that we solve in general here. We will do the same way. First step, also apply the plus transform on both sides. So you get Laplace transform of f of t equals Laplace transform of 1 plus Laplace transform of t minus 8/3 Laplace transform of integral from 0 to t tau minus t cubed f of tau d tau. And now this is Laplace transform of f of t equals Laplace transform of 1 is 1 over s. Plus transform of t is 1 over s squared. And here you've got to be very careful. So minus 8/3 Laplace transform, and this here is nothing but negative integral from 0 to t f of tau t minus tau cube d tau. And you make sure you see clearly what is where, because the way it's written, this is not a convolution, but once you put it this way, removing the minus from the cube to put out here, now this is a convolution. So that is 1 over s plus 1 over s squared plus 8/3, and that is Laplace transform of f of t times Laplace transform of t cubed by the convolution theorem. And so Laplace transform of f of t equals 1 over s, 1 over s squared plus 3/8. And Laplace transform of t cubed is 6 over s to the fourth Laplace transform of f of t. And now 2 can cancel here. That's 1 over s. That's 1 over s squared plus 9 over 4 s to the fourth Laplace transform of f of t. And then always what you need to do is solve for Laplace transform of f of t. Bring them to one side. So this is 1 minus 9 over 4 s to the fourth Laplace transform of f of t equals 1 over s plus 1 over s squared. Notice that I am not combining these things. I keep writing them as is. I don't need to make my life more miserable by combining them. It's useless work. And now here I can bring the common denominator, send it back there. So it's going to be 4 s to the fourth minus 9 over 4 s to the fourth Laplace transform of f of t equals 1 over s plus 1 over s squared. From where we can get Laplace transform of f of t equals, now if I multiply the whole thing by 4s to the fourth, see what's going to happen. I multiply by 4s to the fourth, this becomes 4s cubed, and the second one becomes 4s squared over 4s to the fourth minus 9. Are we good? All right, now here to solve this, we got to remember the things that we are used to. So this is 4s cubed plus 4s squared over, this is 2s squared minus 3 times 2s squared plus 3, right? Everybody agrees with this?
Yes.
So now what we need to do is to do partial fractions with these. So I'm going to say 4s cubed plus 4s squared over 2s squared minus 3 times 2s squared plus 3 equals as plus b over 2s squared minus 3 plus cs plus d over 2s squared plus 3, and do the partial fractions. That leads to 4s cubed plus 4s squared equals as plus b times 2s squared plus 3 plus cs plus d times 2s squared minus 3. Now we can choose the numbers to plug in as we used to do to solve, or we can just write the system of equations and solve it. I'm gonna go the second way. So I'm looking for the coefficient of x cubed. On the left, it's 4. On the right, what is the coefficient of s cubed? We take everything that turns into s cubed. That's as times s squared. So that is 2a. And then cs times 2s squared plus 2c. So 4 is equal to 2a plus 2c. And then I look for the coefficient of s squared. On the left, it is 4. On the right, to get s squared, I need to multiply this by b. So that's 2b. That's it for this one. That's the only way you can get s squared from here. And then from the other one, you got 2 times d. That's the only way you can get that as well. Then I go look for the coefficients of s. On the left, it's 0, because there's no s on the left. And on the right, how do I get s on the right? By taking as times 3, so that's 3a. How do I get s in the second one? By taking cs times minus 3, so that's minus 3c. And right here, you see that a is equal to c, right? And so a is equal to c, and 2a plus 2c equals 4. So if you take this equation together with this, that leads to a equals c equal 1. Because a is equal to c and a plus c is 2. Does that make sense? And then I look for the constant. On the left, I have no constant, so 0. And on the right, to get the constant, I need to multiply b by 3, so that's 3b. Then I need to multiply minus 3 by d, minus 3d. And so here I get b equal d. And using this first equation, b is equal to d combined with this gives you b equal d equal 1 as well, right? So all ABCDs are 1s. So we got them. And we report that four s cubed plus 4s to the squared over 2s squared minus 3 times 2s squared plus 3 equals s plus 1 over 2s squared minus 3, just s plus 1 over 2s squared plus 3. That's what we get so far. And that's Laplace transform of f of t that we got like that. And therefore, what happens is we just say, okay, f of t equals inverse Laplace transform of s over 2s squared minus 3 plus Inverse Laplace transform of 1 over 2s squared minus 3.
Hey,
In-
Dr. Longlaw, could
Yes.
you move the paper more into the middle? The top part's like a little too bright to read. That's a lot better. Thank you.
Is that okay?
Yes, sir.
All right. So it splits into these 4 things, and right now what you need to do is get the 1/2 here. Inverse Laplace transform of s. There is some art in this one, minus 3/2. And then you can put here root 2 over 3 inverse Laplace transform of root 3/2 over s squared minus 3/2. And get the 1/2 out first. And then 1/2 inverse Laplace transform of s over s squared plus 3/2. And the same thing we did here, which is going to give you 1 over root 6 inverse Laplace transform of root 3/2 over s squared plus 3/2. So technically this is done to make sure we get the forms that we are used to. This thing is 1/2 cosine hyperbolic of root 3/2 t. 1 over root 6 sine hyperbolic of root 3/2 t. 1/2, and this is cosine of root 3/2 t, and that is 1 over root 6 sine of root 3/2 t. Any questions? In the previous problem, what we actually got in the end here was just the convolution, and you still needed to add to it this part to get the solution of the problem. I think I did not write that down. So the answer y of t is this plus and the plus is e to the 2t plus 2t e to the 2t, which is the piece that we had before the convolution, and all the answer we had here was just computing that convolution. So that's the final answer to that problem, has to have these 2 things added. All right, do we have any questions about this? All right, let me give you one problem that I hope to solve. We got f of t plus integral 0 to t, f of t, t minus tau d tau equals t. And so solve. I'll give you 5 minutes, and we look at it.
Bien reçu, merci aussi d'avance. Après le rendez-vous lundi, je vous tiendrai au courant de la suite du rendez-vous.
Dr. Longland, what's inside that integral? It's kind of hard to see there. Okay, that's better. Thank you.
Just adjusting these. Sometimes I do prefer to have the black and white show up, which makes things a little better. We almost forgot lately about putting some music in this class when we are solving problems. Sometimes it's so calm that I feel like maybe I'm not here. So maybe I should just try to have some motivational speeches while you guys are solving the problems. I don't know. Anyone knows what's going on in this country now? I've been able to watch TV since February. Anyone with the correct answer already? This one shouldn't be long. I mean, too long.
I think I have the answer.
All right. More than happy to write it down for you.
Okay, so the first thing I did, which I now realize I didn't have to do, was I subtracted the integral to the other side, but I don't know if you suggest to do that or not, because then you have to take it back to the other side. But
Not technically understood at all.
yeah, I don't know why I did that. But I took the Laplace transform of both sides.
Okay. And then here. Just put that Laplace transform where it goes. Next.
And because of the convolution theorem, that chunk, the Laplace transform of the integral, all of that turns into, the Laplace transform of f of t times the Laplace transform of t.
Good. Equals Laplace transform of t.
And then the Laplace transform of t is 1 over s squared, right?
Mm-hmm.
So then it's, is equal to 1 over s squared.
Beautiful. And then from there, you just see something coming out just like in heaven. So that'd be s squared plus 1 over s squared, and they all cancel. And this is the beautiful thing you get, right?
Yes.
Okay, so what is f of t?
Isn't it sine of t?
90. That's it. Beautiful. Thank you very much. Any questions on this? Beautiful, simple, and short answer. Any question at all on everything we've been doing till now? We have 10 minutes left. If no question, then I'll give you another problem for the last 10 minutes. So I've solved a lot of them already. You got to solve yours now. Oh, okay. Let me give this funny one. Y prime of t equals 1 minus sine of t minus integral 0 to t y of tau d tau. And it comes with an extra y of 0 equals 0. All right. 5 minutes, and then we look at it for 5 minutes and we're done, and we go home. And technically, we say welcome to the test next week. Technically started working again like a normal human being this today because my pains are almost over, so I can put my legs on the floor and feel them. So praise the Lord, they say. Wow, this one looks nice, right? Let us try to do this one quickly. Got only 7 minutes left. All right, please. Who has something to say here? Do you want to go, Nathan? Oh, I say Ethan.
I'm almost finished with it, but I can go ahead and start working it with you.
All right, all right, all right.
Okay, I started by taking the Laplace transform of both sides again.
What is the
And
Laplace transform of y?
prime. That's going to be the Laplace transform of y minus y of 0, right?
Can you say that again?
The Laplace transform of y of t minus y of 0.
Something before.
No? 1 over s? Is that what I would just ask?
Mhm. Then y of 0 is given as 0. That's why it's given. So here is S Laplace transform of y equal Laplace transform of 1. That's 1 over S. Plus transform of sine t, 1 over S squared plus 1 minus. And this is 1 over S Laplace transform of y. That's why it comes to this side. It becomes S plus 1 over S Laplace transform of y equal 1 over S minus 1 over S squared plus 1, which turns into, and then sometimes here people are lost because they don't do the proper algebra. S plus 1 over S is first computed as S squared plus 1 over S. And then it's sent to the other side. S on top cancels with the S and get Laplace transform of y equal 1 over S squared plus 1 minus S over S squared plus 1 squared. That's it. So y of t equals this is sine t. What about this one? Minus this here looks like the derivative of the 1 over S squared plus 1, except that we are missing a 2. So we are missing the 2 there, so we can put that 2 and get 1/2. And then you would have with this minus and minus derivative of that, which is the Laplace transform of t sine t. Ta-da!
I was close.
Very close, right? All right, so technically that's our life, and that's where we end today. And I'll say thank you for listening to me all this week. And if you have questions, please feel free to ask. If not, it's till next week.
Dr. Long, I have a quick question.
All right, go ahead.
Just because I don't want to have to send you an email. Is it okay? Can I meet with you tomorrow for office hours? Because I have a class during your typical office hours.
Now, what time was that?
Last time we met at like 3, but just like if you can give me a time, I can work with that.
All right, 3 then.
Perfect. I'll see you tomorrow.
Oh, wait a minute, because at 3, I have a meeting tomorrow at 3, so probably
I'm so free
maybe
before.
4
So
4 is better.
4. Okay, perfect. I'll see you at 4.